Welcome pre-calc students to the homework help video, page 128, 23 through 33. These are the function word problem types of problems, and they're pretty difficult. So if you need some help on these, let me help you and make sure you really understand this math. Okay, number 23 reads as follows. Once I get over there in the book, creative landscaping has 60 yards of fencing to enclose a rectangular flower garden. If the garden is X yards long, express the garden's area as a function of the length. Express the garden's area as a function of the length. So we're going to try to write the area as a function of the length. But hold on one second, please. For some reason in this problem, if you look at the third line down, it says the garden is X yards long. So in this problem, they want us to use X instead of L, which is fine. That's their prerogative. But usually we would put an L there. But we're going to do what they say. They want us to write area as a terms of length, area as a function of length, and they want us to use X for length. I'm going to write that right over here. X equals length. Okay, well, let's go ahead and get a picture. We know what we want to do. We want to write a function so that we have a over here and then only variables of x over here. So let's go ahead and get a picture of this garden, I guess, that we're going to draw. And there it is. And now let's go ahead and see if we can't fill some things in. First of all, we know that we have 60 yards of fencing, okay? So I guess what I'm going to do is I'm going to call my length X, like they said to do, and I could also call my width, I guess we'll just call it Y. Since we're using X, I'll use X and Y. So there we go. Now I know if I take X plus X, that's 2X, plus Y, that's 2Y, I would get 60. Right? Because it says I have 60 yards of fencing to use. So I'm assuming I'm going to use all of the fencing, and if I put all of the fencing up, that's going to be 60. Now I did make one mistake, and I apologize. I got a little ahead of myself. We usually write a formula over here, and I forgot to do that. Usually we write a formula that will help us get started. So we're trying to write a function of area, and area of a rectangle is what? Length times width, right? I mean, that's the usual formula for area of a rectangle. And of course my length is X and my width is Y. So that's the normal formula I would use to find the area of this right here. I would take X times Y. But the problem with that is, look, remember I want to write a function that has A over here and only X is over here. And in this model, I have an X and a Y. So I want to get rid of this Y. This Y needs to be taken away somehow. I'm going to have to substitute something in for Y. Well, that brings me back down here to this problem. And I apologize. I should have done this first and then gone over here, but that's fine. So now I look at this equation. I'm like, wait a second. If I want to put something in for Y, that means over here I can get Y by itself. So I'm going to bring the 2X over and make the 2X negative. And now I'm going to divide everything by 2. And look at that. What does Y equal? 30 minus X. So what can I put for Y right here? 30 minus X. So I come over here and I have A equals X parentheses 30 minus X. And now let's go ahead and simplify. Area equals X times 30, 30X, X times X, negative X squared. Now there's only one more thing we have to do, and that's to write our equation in functional notation. So I have an A here and an X over here, so I would write A of X equals 30X minus X squared. Look at that. There we go. We did it. And so now we have area as a function of X, or really we have area as a function of length because X equals length. So there we go, we did it. That's all they asked us to do. Okay? Let me get a drink here and we'll continue on. Alright, number 25 is a little more difficult. 25 reads as follows. A hot air balloon rises and it's going up at a rate of 120 feet per minute. The balloon is tracked for from a rangefinder on the ground at point P, which is 400 feet from the release point. And D is the distance from the balloon to the rangefinder. So let me stop and show you something here in the picture you need to see. Please look up here. What they're saying is this. The man standing here is 400 feet away from where the balloon was launched. See it? 400 feet. And the balloon is rising at a rate of not 120 feet, but 120 feet per minute. So every minute it's going up 120 feet. And then here's the distance from the balloon to the guy over here at the rangefinder. Now, you do understand, as more time passes, the balloon will get what? Higher. And as the balloon gets higher, the distance from the balloon to the man increases, okay? So it's not a set distance the man is away from the balloon. It's changing with every second. As the balloon rises, the balloon is getting further and further away from the rangefinder, or the guy holding the rangefinder, okay? So with that in mind, now let's continue on and read the problem. Let D equal the distance from the balloon to the rangefinder. Well, that's fine. We already saw that right here. Here's D right here. That's the distance from the man to the balloon. That's fine. And T is the time. We can see that right here, 120 T. And we're going to talk about that in a second, so don't worry about that. Since the balloon was released, here it is. Express D as a function of T. Look at the very last sentence, please. Express D as a function of T. So in my final answer, I would like to have D over here, and then all kinds of numbers and stuff, but the only variable I'm going to have is going to be T. That's D as a function of T. Distance as a function of time. Okay, well, let's go ahead and let's see if we can't cut out this triangle here. And let's see if we can't get some distances. I think that'll really help, okay? So I'm going to grab this. I'm going to pull this down here if I'm able to, and put this back up here. Okay, so I cut the triangle out. Here it is. And let's see if we can't label some stuff on this triangle, okay? First of all, we know this is 400 feet. Now, this here needs, I'm not sure why I put a T there, sorry about that. This here also needs to be a distance, right? This needs to be a distance. Well, don't forget, distance equals what? Remember? Rate times time, right? I mean, that's what distance equals, rate times time. So is 400 a distance right here? Yes, it is. Is D a distance right here? Yes, it is. I want both of these to be a distance. Why, Mr. Earhart? Because if this is a distance and this is a distance, then I know the length of this line, I know the length of this line, and I can use Pythagorean theorem. It's a right triangle. I can use Pythagorean theorem to write this distance. So the formula I'm going to use, remember, let's come down here and do some quick scribble work. Remember, Pythagorean's theorem is L squared plus L squared equals H squared. Take the square root of both sides, and you have the square root of L squared plus L squared equals what? Your hypotenuse. So this hypotenuse right here, this distance, we're using D. I better put D subscript 2 here. This is D right here. This distance D right here is the hypotenuse. I could say that D equals, well, it equals this right here, the square root of 400 squared plus D subscript 2 squared. The only problem with using that formula is I want a D here and I want T's over here. And right now I have a D, but I don't have a T. Well, that's why they put 120 T right here, guys. Look, distance is the same thing as what? Rate times time. Got it? So instead of putting D2 right here for my distance, I could really put, what's the same thing as distance? RT. Now, instead of putting RT, I can put 120 because they tell you the rate. What's the rate of the balloon? 120, what does it say? I've got to look. 120 feet per minute. So that's your rate. So for R, you put 120, and then you're left over with T. So there we go. This is your rate, 120, and this is your T, RT. So there. Now I have 400 for this length right here. And I have 120 T for this length here. So for D right here, where I used to have D subscript 2, I can put 120 T squared. So now I have distance equals 400 squared plus parentheses 120 T, close the parentheses, squared. There we go. So I now have a function. Look what I have here. I have a function in which it's distance based on time, or distance as a function of time. Okay? Now, we do have to do some simplifying, of course. We can square the 400, and we can square the 120t squared. And if you do all of that correctly, I did not do it ahead of time, and I should have. That's my fault. 400 squared, let me very quickly write this down here. Grab my calculator. 400 squared would be 160,000, and 120 squared is going to be 14,400 t squared. All right, and there's a plus sign here. You really can't add them together because they're unlike terms. So you would have d equals the square root of 160,000 plus 14,400 t squared. And of course, in your final answer, I do want functional notation. So what you'd have to put would be d of t. And there it is, distance based on time, or distance as a function of time. And I think that's all they ask us to find. Yes, it is. Okay, so very good. Moving on to the third problem. A rhombus is inscribed, reading number 27. A rhombus is inscribed in a rectangle that is w meters wide with a perimeter of 40 meters. Each vertex of the rhombus is a midpoint of the side of the rectangle. Express the area of the rhombus as a function of the rectangle's width. Okay, here we go. Okay, first of all, I'm going to write down what they've asked us to do. Area as a function of the width. So, area as a function of the width. So I'm trying to come up with a function, a model, an equation, a formula, whatever, that has a over here, and the only variable over here is a w. So let's go ahead. We're dealing with the area of a rhombus. That's what we're trying to do. If you'll look at the, the fourth line in the problem, it says express the area of the rhombus as a function of the width. So we're dealing with the area of a rhombus. So my suggestion is to write down the formula for the area of a rhombus and then see if we can't manipulate it. Now, you might not know this, so I'm going to help you, okay? This is geometry, and so some of you might not remember this, or maybe some of you have not had geometry yet. But a rhombus has diagonals. So there's one line going straight across. Not the best drawing, but I think you get the idea there. And then here's another diagonal coming down. Rhombi is plural for rhombus, okay? Some say rhombuses, that's okay, but most say rhombi. So all rhombi have two diagonals. And here's how you find the area of a rhombus. Are you ready? Its area equals 1/2 times diagonal 1 times diagonal 2. Isn't that simple? So all you have to do is know the length of this line here and the length of this line here, and then you have you're able to find the formula. So there we have the exact way to find the area of a rhombus. But the problem is this: they want area here and W's here. We have area here and a D and a D. So somehow we've got to make substitutions for these D's right here. Okay? So I'm going to have to think about this. I'm going to drag this over here. Maybe I shouldn't have done that because the diagonals don't go with it. Let's see if I can't do this and that and that. There we go. Now, well, let's see if we can't figure some stuff out here. First of all, you do understand something, don't you? The length of this diagonal right here is the exact length as this line here. You understand that, okay? So one of my diagonals I can call W right here, okay? So that's pretty simple to understand. Now, They also tell us the perimeter of this rhombus is 40 all the way around, correct? So I guess if this is W right here, width, I guess I'm going to call this right here my length, if that's okay. Okay, so here's what I have. I know it's a perimeter of 40 all the way around, right? So I have a W here, right? A W here, right? A length here and a length here of my rectangle. And again, if you'll look at the third line, it says, or the second line, the rectangle has a perimeter of 40 meters. So I know if I take W plus W, 2W, plus L, 2L, that's going to equal 40. Now, think about this. If this is W right here, do you see this W? Isn't this length right here, W, the exact same length as this diagonal right here? So let's call this our diagonal 1. So for diagonal number 1 right here, I can substitute what? W, because W right here is the same as my diagonal here. Now, for this diagonal here going down, that's the same as my length. So I could put an L right here, but I really don't want to do that because remember I want A's over here and W's over here. So as I look at this right here, if I add up all four sides I get 40. Can I not get L by itself and then make a substitution right here for my L? Could I not do that? Let's see. 2L equals 40 minus 2W. Now divide everything by 2. L equals 20 minus W. So where the L is, I can now substitute 20 minus W. And now you can just take your W and multiply it through and then take your 1/2. In fact, I would do it like this. To simplify this, I would say 1/2 times W is 1/2 W times 20 minus W. Okay, 1/2 times W is 1/2 W. Now times this, and you would end up with A equals 1/2 W times 20 is 10 W. 1/2 W times negative W is negative 1/2 W squared. Now, it looks like we've accomplished our goal. They asked us to write the area of the rhombus as a function of its width, or as a function of W, and we did it. There it is. Now, the only thing left to do, and I am going to require this, is I want you to write it in functional notation. So I have an A here, W's over here, so A of W equals 10W minus 1/2 W squared. There we go. We did it. We wrote the area of the rhombus as a function of the width. Okay, halfway done with the homework. 3 more to go. Let's take a look at number 29. A device used in golf to estimate the distance D in yards to a hole measured the size S in inches. That the 7-foot pin appears to be in the viewfinder. This device will tell you how far the golf is from where you're standing. And they want us to express the distance as a function of S. Now, this is a fine drawing, but I'd like to show you, I don't think it's really superb. Let me explain what they're saying here. You're standing here with your eye, and you look, and then you take your hand right here. Okay. I'm not an artist. That's supposed to be your hand, and you're holding this device in front of your eyes and you're looking through it. And as you look through it, it takes this 7-foot pin over here, which is so many yards away, maybe 100 yards away, whatever, and it shows up here in inches. And so when it says S in inches, it's referring to this length right here. Okay, so if it's okay with you guys, let me take this diagram. It's not really drawn very well, in my opinion. Not that I could do any better, but and let me kind of break it down so it looks like this for you. Are you ready? It looks like this. You have a really long triangle like this, and I should have used the figure recognize thing. There we go. Okay, and now it looks like this. That's basically what it is, okay? And this is your flag over here. This is your flag. This is your flag right here. And this is the viewfinder you're looking through right here. So basically what you have would be two triangles and a little triangle and a big triangle. That's all that we have, okay? So having written that for you, I wanted to kind of describe it. So see this distance D in yards right there? Do you see that? That would refer to this length down here also. They just have it going straight across like this, across the top like that. Well, I'm just going to go ahead and say it's the distance down here all the way across. And then from here to here is 6 inches, so 6 inches runs from here to here. And this is your S going up right here. This is your S going up and down. I'll put an up arrow and a down arrow. And this over here, of course, is 7 feet. Now, this is a really difficult, actually it's a very easy problem. Well, let me go ahead and read the rest of the problem. Estimate the distance as a function of S. And if you'll notice, S here is the inches going up. So they want you to write the distance as a function of S. So you're going to have a formula in which you have D only over here, and all of your variables over here are S's only. D of S, distance as a function of S. Okay? Now, it's really an easy problem. I could never get the answer they have in the back of the book as I work this out, and I'm going to tell you why. It's really confusing with how they have inches, yards, and feet all in the same problem. And I don't want to be critical or make excuses, but they really didn't explain if you're supposed to. I do believe you're supposed to leave this in inches right here, because I believe the device is set up in such a way that it knows this is feet over here and this is inches over here, and thus it gives you out the distance. I believe the machine is set up that way. I believe. I'm not a golfer. But either way, we're just going to have to kind of guess and go with it. And so what I want to show you is this. You might not have known this, but whenever you have a little triangle like this inside of a big triangle, and this line right here is parallel to this line here, and you should have learned this in geometry, okay? Whenever this line here is parallel to this line right here, that means your two triangles are similar. And so what that means is this. Now watch this. That means we can write the two triangles separately, and they're proportionally similar. So here's my little triangle right here. In fact, I'm just going to cut it out. Here's my little triangle right here. And then here's my big triangle right here. And those that might not have had very strong geometry, or maybe not geometry at all, you might not know all this, so please pay attention, okay? These two triangles are what we call proportional. So I know this length here is 6. I know this length here is S. I know this whole length here going across is D, and I know this is 7. Now the only problem is this is inches, this is feet, and this is yards, okay? It says D in yards. All right, so this is kind of a confusing problem. And again, I'm not making excuses. I just wish they would have explained a little better what this thing does for you, as in terms of, do we need to convert stuff over to in all inches, all yards? I've tried it many different ways, and I couldn't get the answer they were coming up with. So they need to explain themselves better in the problem, or maybe, just maybe, they have the wrong answer in the back of the book. I'm not sure. So being a mathematician and not knowing what else to do, I only know how to solve these types of things so that they are inconsistent, so that they are in complete, consistent units of measurement. And so it's easier to make everything inches than yards so that you don't have fractions. So that's what I'm going to do. Okay, so this is 6 inches right here. This here says S inches, so this is in inches. This is in feet. So I'm going to take my 7 feet, and instead of putting 7 feet, I'm going to use 84 inches. And then I have D yards. Well, a yard should get multiplied by 36 to get it in inches. In other words, if you had 2 yards, you would take 2 times 36 because there's 36 inches in 1 yard, and 2 yards would be how many inches? 72. 1 yard is how many inches? 36. So you always take the yards and multiply it by 36 to convert it over to inches. So this is in yards, so I'm going to take my D, which is in yards, and multiply it by 36 to get inches. Now again, this is probably totally wrong, and if you're a golfer and you know how to use this device, you're probably chuckling. But again, I'm not experienced with golfing, so I'm going to make everything become inches. Now here's how we set it up. Because we have similar, that symbol means similar, because we have similar triangles, I can say 6 over 36 using a ratio equals, and it wouldn't be 36, sorry, it'd be 36D. 6 over 36D equals S over 84. 6 over 36 equals S over 84. And now look, I have all S's and D's. So all that I have to do is get D by itself, and I will have a function D written in terms of S. So whenever you have two ratios equal, you should know by now you can cross multiply. 36D times S would be 36DS equals 6 times 84. I'm doing that in my head. It would be 24, carry your 2. That'd be 48, 504. All right. Now we're going to take 504. Now remember, we want to get D by itself, right? You want to get D all by itself. So I'm going to divide by 36S. That way these cancel out, and I'm left with just D. So I'm going to divide one side by 36S. I'm going to divide the other side by 36S. 36 cancels, S cancels, I'm left with D. So D equals, and then I have 504 divided by 36, and you'll get 14. So 14S. I think that is the answer in the back of the book, so maybe we did actually nail it. But anyways, D equals 14S. Now, remember, you've accomplished the problem. You've solved it. Good job. Well done. But you have a D over here and an S over here, so you write your final answer in functional notations. D of S equals 14S. And there we go. That's all they asked us to do. Okay? So you can put in certain inches, and you will get out how far the ball away, the pin is away from the ball. If your ball is setting right here and you get ready to hit it, you can put in how many inches you have here in the view screen right here for us, and you will get out how many yards the ball is away from the cup where the hole is here. Okay. All right. Hope that's made sense. This is a function distance based on S inches. Okay. Continuing on. Let me get a drink here. Two more problems and we're finally done. Let's take a look at number 31. A daycare center has 30 feet of dividers with which they are going to enclose a rectangular play space in a corner of the room. We've kind of done one like this before. The sides against the wall require no partition. Suppose the play space is X feet long. Express, letter A, express the area as a function of X. Express the area as a function of X. Okay, so we're going to express area as a function of X. Area as a function of X. There it is. So with that in mind, I'm going to slide this down here. We'll come back to this later for the very last part of the problem. We'll use that in problem C, or part C, I believe. So we want to write area as a function of X. Well, the best thing we should do is get a picture of the room. There's a room. And then in the corner, we're going to set up a play area using partitions. Okay? And we do it in the corner. So very good. It says to call the play space X long, and I guess we'll go ahead and use Y for the width. Okay, so it's X long and it's Y wide. Okay, right there. So let's see. I've got to write a formula for area. Well, first of all, it's very obvious to me that area equals X times Y. Isn't that true? That's how you find the area of a rectangle, X times Y. So I could write area equals x times y. Obviously that's not going to help because I want just x's over here and I have a y. So I'm going to have to do something to get rid of this y right here. Somehow I'm going to have to make a substitution so that the y is gone. Well, here's what I'm thinking. I know I have, according to the problem, 30 feet of partitions to use. 30 feet. So I'm not sure how long this wall is, or this partition, but I know if I add the two together, x plus y, I should get 30. And now that's really good, because if I bring the x over and make it negative, I get y equals, look at that, 30x. So what can I put for y right here? For y, I can put 30 minus x. So now I have area equals x, then parentheses, and then 30 minus x. There we go. So I did it. I now have the area as a function of x, or area in terms of x. And that was my original goal right up here. Now, the only thing you have to do is write it in functional notation. So I have an a here, and x is over here. So I write a of x equals 30x minus x squared. There, I did it. Part A is complete. I wrote area as a function of x. Okay? Very good. Now, part B says use the graph, find the domain of the function. Now, when you look at this function, usually you would say, oh, the domain is x, and x is all real numbers. Usually, yes, but don't forget, x is referring to the length. And you only have 30 feet of partitions, so there's no way x can be 0. How can you have a 0 length? That's impossible, where you don't have any rectangular room over here. So we know x has to be greater than 0, but there's no way x can be bigger than 30, because you only have 30 feet to use for both of these partitions, so you know your x has to be less than 30. Think about it. There's no way your x can be 30. You only have 30 feet to use. Your x has to be less than 30. So you put your smaller number here, you put your larger number over here, you put your x in the middle, and you point your arrows to the left. Now do not put equal signs, because x cannot equal 0 and x cannot equal 30. X is greater than 0, less than 30, non-inclusive. So there's your domain. There's your domain. That's pretty simple, okay? Now, the last part says, using the graph given, and there is a graph given to us, using the graph that's given to us, determine the dimensions that yield the maximum area. Well, come on, think about it, guys. I mean, they shouldn't have put a y here. This should be an a. That is incorrect. It's a in terms of x. So a of x equals, I forget what we had, I'm sorry, I apologize, it was something like 30x minus x squared or something like that, but a is the area and x is the number of the length. So look at this, here's the highest point on the graph. So isn't that the highest point up you're going to go on a? Sure it is. Do you see the graph going any higher than this? No. So what's the highest point on a that this graph is going to go? Well, right here. That's the highest point. And what is that high point? 225. So it looks like to me that the biggest area you're going to get is 225. That's the biggest area. And what x value gives you 225? 15. So 15 is your x value that gives you an area of 225. So when x is 15, your area is what? 225. So back to that drawing we had earlier right here. Here's your x and here's your y. If you're saying x is 15 and you know you have 30 feet to use, then y must also be 15. So you end up with a square, which, by the way, that's not a mistake. A square is a rectangle. Okay, all squares are also rectangles. Rectangles are not squares. Okay, the definition of a rectangle is a parallelogram with 4 right angles, and a square is a parallelogram with 4 right angles. So a square is also a rectangle. But anyways, so if x is 15, y has to be 15. So the dimensions of the room that give you an area of 225. And by the way, again, isn't that the biggest area you'll get? Sure, that's the highest point according to this graph. Okay, we're looking at the graph. According to this graph, that's the highest point. So the biggest area you're going to get is 225, and that would be a 15-foot by 15-foot dimensions. And there we go. That's it. So good job so far. One more problem and we're finally done with this homework assignment. Okay, number 33. I'm going to slide this down here. In fact, I think I'm going to go ahead. Yeah, I'm going to slide this down here for right now. We'll come back to that later. In fact, I think I'll put a new page up here, grab this, pull this over here, and we'll leave this here. I'm not sure why the picture came out so light, but that's okay. All right, number 33. Let me turn over a page and read it to you. You have a 12 by 12 piece of cardboard. You're going to cut out square corners so you can fold it up. And letter A, express the volume as a function of length x. Express the volume as a function of x. So there's our goal right here in front of you. You are to write a formula or a function or an equation that has v here and the only variables over here are x. Okay? All right. Now that formula, that function, that model is supposed to model this box, the volume of this box in terms of x. Now, this will not be super easy. This is the hardest problem we're going to do. So please take some really good notes and listen, okay? First of all, like I've taught you, you want to draw a diagram. They've already given that to us, so we're going to move on. Next, let's write a model for volume. Even though it might not fit the description we're looking for, let's write volume. Now, if you don't know this, let's go back and review geometry real quick here. I'm not an artist, you guys know that, but here's a rectangular prism. In order to find the volume of this, you take the length times the width times the height. That's how you always find the volume of a rectangular prism. And this is a rectangular prism right here. So in case you've forgotten that, now you know. In order to find the volume, take the length times the width times the height. Now the only problem with this, we're not even close. I mean, look, it's kind of funny. We want a V here and we have a V here, but we want only X's over here. We have an L, a W, and an H. So we've got to get rid of a lot of letters here and put some X's in here somehow. Somehow we've got to get some X's in here for the L, the W, and the H. Okay, so first of all, let's come over here and look at our picture. We cut an X length away and an X length away. Do you see that? So when you fold this up in the air, the height will be X. Now if you can't see that, take out a sheet of paper and cut 1 inch and 1 inch with scissors, 1 inch, 1 inch. Now I know it didn't say 1 inch, just bear with me. Cut out an inch and an inch, an inch and an inch, and then fold your paper up and you'll see the height right here. The height will be 1 inch. So that is true. So whatever you cut away is how high this is going to be over here. So I know the height is X, so booyah, I can at least put an X for H, right? So the H is gone. Good deal. I'm 1/3 of the way done. I've still got to get rid of this L. I've still got to get rid of this W. Now, let's take this picture right here and let's just draw it down here, okay? So here's the original piece of cardboard that you had, okay? And so you're going to take a pair of scissors and you're going to cut. Oh, hold on. Remember, it tells us it's a 12 by 12 piece. So I know the distance from here to here is 12 centimeters, okay? It's very important you make note of that. And the length of this side here will also be 12 centimeters, okay? Very important we make note of that. Now, notice that we've cut away this piece here and this piece here, and that is X and X. That's very important you see this. Watch carefully. And I'm cutting away X and X distance or length. And I'm cutting away an X length and an X length, and then I'm cutting away X length and X length. Now can I please show you something? You see this 12 right here? From here all the way across to here it's 12, but you took away from that whole length, you took away an X and you took away in x. So 12 minus x, once you took that away, this whole length right here is really 12 minus 2x right here. This is a hard problem, but it really is, because we can look at it like this. I think it'd be better explain if I did this. See this right here? This would be 12 minus 2x right here, this length from here to here, because you cut away an x and you cut away an x right here. Okay, so that's important, because now I know this length right here is 12 minus 2x. Now it's going to be the same thing here too, by the way. You have a whole length of 12, you cut away an x, you cut away an x, so you cut away 2 x's. So this length right here, because you took an x away and an x away, that length right there is going to be 12 minus 2x. So the length right here, or the width, whatever you want to call it, they're the same, so it doesn't matter, of this box is 12 minus 2x. So for this length right here, I'm going to write it real small. For this L, I'm going to put 12 minus 2x. And for this W right here, I'm going to put 12 minus 2x. Let me write it a little neater now, okay? So I have V here and x is over here. I would write V of x equals parentheses 12 minus 2x, 12 minus 2x, and then an x. Alright, so there we go, you did it. Now would I make you simplify that? Well, if I did, you would just simply take 12 minus 2x times 12 minus 2x. You would get 144 minus 4x plus 4x squared, all of that times x. So then you take this x and you multiply it through. So you would have 144x minus 4x squared plus 4x cubed. But I'm not really super concerned with that right now. I just want you to mainly see that we have accomplished part A. Part A asked us to write v as a function of x, or volume as a function of the length, and we did that. There it is. I mean, we have v and we have x, so not easy, but we did it. Now part B says find the domain. Okay, now normally when you look at a function like this, the domain's all real numbers. I mean, x can be anything, but hold it, guys. X is referring to this length of 12 right here, okay? Right here all the way across. And so look, please watch this. It's so hard to see this if you don't watch this, okay? X is the amount you're cutting away, correct? X is the amount you're cutting away. Now look, you cannot, if you cut more than half, watch this. If you cut away 6 and 6, that means you're cutting away 6 and 6. You have nothing left. You've just cut the thing up into 4 pieces like this, because half of 12 is 6. Now look at this. If you went over 5 and down 5, and then you went up 5 and down 5, and same thing over here, you would have a really weird shaped box, but it would still work. You would fold this up and fold, you'd have a really long tubular box. It would look like this. Something like that, really tall and narrow. But anyways, my point is this. They're asking you what x, the domain is x, and they're asking you what x can or cannot be. And I'm telling you right now, x is what you're cutting away, right? Look right here. X is what you're cutting away. Well, since you can't go past 6, if you cut away more than 6, you're cutting the whole thing away. Your x has to be greater than 0. Obviously, you have to cut something away, but it's going to have to be less than 6, because 6 is half of this length, and there's no way. If you go to the halfway point and cut, all you're doing is cutting the thing in 4 strips of cardboard, and that's not going to help you do anything. So not easy to see, but the truth is x has to be greater than 0 and less than 6. Now use the graph of the function shown below to determine the dimensions that yield the maximum volume. Okay, this will be really interesting. Let's see if we can do this here. So we're going to take a look at this graph real quick that they've given to us. Here it is. And we're going to look at this. Now remember, they really should not have used a y here. They should not have used a y. This should be a v. This is your volume, and this is your x, your length, okay? So I think we have, let me see if I can't pull this over real quick and use this over here. All right, there we go. Now, what this ordered pair is saying, you have a volume of 2. Sorry, that's incorrect. You have a volume. What's the highest point on this graph? They want to maximize the volume. Well, the highest point is here at 128. So you have a maximum volume of 128 when x is what? 2. When x is 2. So remember, your height is x, so you want your height to be 2, and your length here is what? Wasn't it 12 minus 2x? Is that correct? Isn't that right? 12 minus 2x? Look at your homework there, your notes, you'll see that. So where the x is, I'm going to substitute 2, because when x is what? 2. I should have put an x there, not a 2. That's my fault. There should be an x. When x is what? 2, your volume is 128, and that's the highest volume you can get based on this graph. So when x is 2, put a 2 here, 2 times 2 is 4, 12 minus 4 is 8. So when you have a length of 8 and a width of 8 and a height of 2, you'll get your maximum volume of 128. So what's the dimensions? The dimensions would be 8, let's see, take a look, is it inches? It's centimeters. So your dimensions would be 8 centimeters by 8 centimeters by 2 centimeters, or a length of 8, a width of 8, and a height of 2. That dimension right there would give you a volume of 128, and that's the highest volume possible. Guys, I've warned you, these are difficult problems. I know they're difficult. You might want to turn the video off and work every single one of these problems again without the help of a video. That might be what you have to do this time to master this material. Okay, it's up to you. Call or email if you have any questions, and I hope this homework help video has been a help to you.